and welcome to episode 71 of the Gaslec Podcast. And thank you very much indeed for watching here on Spotify and on YouTube as well. And if you're listening on the audio-only platforms as well, thank you very much indeed, guys. This week's episode, I'm going into the electrical side of heating systems, commonly the 2 and the 3 port valves. So if you're listening on audio only, you might want to see if you can experience us within the video side of what we do, as you might find it a bit more beneficial. But I'll try my best to explain every single little part that we do. Also, we'll be looking at the history of the plastic water pipe and roughly sort of when it was invented, who invented it, and what material it's actually made for. But first of all, here's my friend Sean to tell you a bit more about the podcast. Homeowner that likes a bit of DIY, or are you a business owner and wanted a bit more knowledge before you make some decisions on your plumbing and heating? Stay tuned to the podcast and hopefully, and welcome back, guys, and thank you very much indeed. So I've had a little mad weekend away with the lads. I'll do a little bit of off-road motorcycling if you ever follow us on social media. On my private page, and we've been away messing around, and it's been an absolute hoot over there in Wales. So it's one of my little guilty pleasures. You don't mind getting wet, you don't mind getting muddy when you're doing that sort of thing. And when you come into the work environment, when I come back to work, all I want to do is grab an umbrella and hide from the raindrops. But give me a motorbike and that's it. I don't care about getting wet. It's amazing. But I'm all back and I'm a bit achy. I'm a little bit unbike fit, well, not bike fit. So I've got some stuff to work on moving forwards. So there's a couple of things I want to go through in this episode of the podcast, really. And it's towards you guys that are coming into the industry or you're very new into the industry about the electrical side of heating. And we're talking about S and Y plan. We're talking about 2 ports and 3 port valves. Now, there are so many conversations that I get into with heating industry professionals and with electricians. So within my background, actually, I've been doing electrical longer than I've been doing gas. So, and that's the truth out there, guys. So I appreciate the electrical side on how it all works and fully understand it. And I'm going to see if I can get it across to you guys to see if I can simplify it and break down some of those myths. You may be working with someone that's gone, oh, it's a witchcraft, it's this, it's that, or we just leave it to somebody else. But you've really got to understand it, guys. And certainly if you're new into the industry, if you understand it, you'll be in the top percentage of even the experienced heating guys out there. So what do we need to do first of all? Safe isolation. Now, I've had loads of electric shocks and they're not big and they're not clever. And everyone's got a story about an electric shock and everyone's got a story about getting cement burns on their knees, lying in wet screed and stuff. So in the UK, there's approximately 1,000 workplace electric shocks or burn incidents reported to the HSE every year, with roughly about 30 resulting fatalities. So that's not just getting a little, oh, ow, that tickled. That's, a massive wallop, people going to hospital, burns, because you will get burns. I've actually got a burn before from getting an electric shock through doing something, looking back on it, rather bloody stupid, be honest. But it's a serious thing. It will take the path of least resistance. And certainly if you're holding something that's earthed, you create that less of a resistance flow. And it's the volt jolt and the mills that kills, as they say, within current. So if you can get more current running through your body, and we're talking milliamps here, more current running through your body, your heart is an electrical organ, your brain is an electrical organ. And if you're touching something, it'll pass through there. And what's in the middle? Your ticker. And that is then what will stop. And if it's a big enough one, you'll start getting burn marks in the creases of your arm. If you've got your arm bent, it will sort of spike across there if you're a bit hot and sweaty. So it's a really serious thing. It may sound like, we're all being a bit over the top and, let's be a little bit cavalier with things, but it's a serious thing, guys. So one of the things that we use here in the heating industry is, I've just gone through one of my bags and I've got a little cheap one here. This is a volt stick or a non-contact volt tester. Now, what we need to be really careful about is this will tell us if there's a live current running through the cable or a live voltage present in the cable, I should say. So, but we can only take it as, personally, I take it as a guide. I don't take it as gospel. You would not want to trust yourself with this thing that costs about 20 quid and trust your life with it. So there's other ways of using multimeters to confirm it, but just from the outside, I'm not going to do a video yet on a multimeter. I haven't got one here, but I'm just going to talk to you about the volt pen. So on this one here, we just turn it on. It's lit up green. It's a bit difficult to see it on the camera. And on here, it gives us a percentage at the bottom on this one. And it's got 70 volts to 1000 volts AC. And that's what we're looking for here. And what I've got here is I've got a electrical cable, which I know goes off to my light there, and the light's on and working. So what I want to do to start with is I want to double check on something that I definitely know that works without turning the thing on and without turning it back. Without turning it off and back on again. So there's a wire. It might go to the radio, it might go to a lamp, whatever it'll be. And I just want to double test it and go, right, that's now telling me that cable's live. So without turning that off, I'm going to go to what I'm working on and then test it again without turning it off, because the very art of turning the thing off and back on again could mean that the thing's gone into a fault mode, and we don't want people getting hurt. So there we are. So this is how this one works. There's fluke pens that we have here at Gaslec, and we've got these slightly cheaper ones here as well. I think I've got them off Amazon, because we do get through them a little bit. But safe isolation is absolutely crucial. And if you're working alongside someone, find out how they do safe isolation. And if safe isolation means that, if you've got a localized fuse spur and you turn it off, it's where you are, and you turn it off and you're in control of it. Sometimes we'll even pop the fuse out, and then we'll put the fuse on a bit of black tape and just stick it on the top of the fuse spur so we don't lose it. There should be a 3 amp on the fuse spurs for heating systems, but I'll just pop it onto the side if I'm not confident that I'm fully in control of it. And once we do turn it off and take the fuse spur out, go back and test with your non-contactor volt stick again. And they do say also, if you're going to work on a boiler or anything metallic, you use one of these to see if the casing is not live. So you can go around the casing and make sure it's dead as well. And they teach you that on your training course as well. So we get there and we make sure it's all dead. Fantastic, awesome. And we've got an issue where we're getting no heating cooling or no hot water cooling. And I really want to go through, guys, with you about 3-port valves and 2-port valves and on the wire inside and how they work. So here we have, and it's a brand new one, and I've took it out of the box. And this is made by Banico Controls, so it was just one we had downstairs, not quite sure where it's come from. Now on here we have A, B, double check, A and B on the, obviously everything for me in the camera is all back to front. So the water comes in, A, B, and now this is printed both sides as it comes across here with directional arrows. When it goes off for A, and the way I remember this is A for air. So the warm water comes up, the hot water comes up, comes out this side, and that goes to air. And air, the way I remember it, is for radiators, for the heating. It heats the air of of what you're putting it through. And the B side goes to the bath. So that's giving us the hot water. That's going through the cylinder coil and then back out again. So A for air and B for bath, and that is probably the most simplest way to remember on the which way round the body goes, because you can take the heads off and stuff like that, but ultimately it's what way round these go, and it's got to go the right way round. So when these are in the unpowered position, they will prioritize straight to the heating coil as it comes across to here. Straight the AB straight to B. So I'm going to go through in a minute why that's quite important to remember that. On the end of this 3-port we have, which is very similar to the Honeywells, it has a lock. So this little lever here, we can lock that in the position, and now what that's gone and done is that's locked over the water from the AB straight into the A, and then that locks that over, so that will only now work in that position, and then that will just spring back. If you don't lock it in, you can probably hear that sort of springing around on the microphone. So these things here called wires. Now, some people, as soon as you start presenting them wiring centres, you start offering them the cables, they go into some sort of strange meltdown. It really is. If you just think about all electrical is a bunch of switches. So that's all it's doing. It's switching, it's getting a signal in from one point and it's switching and then sending a signal out on another. If you just remember, that's all it is, just a series of switching. And that is about as hard as it gets, to be honest. So you're going to open up the wiring centre and it's like an absolute bird's nest. So first of all, guys, don't panic. So if you do take the cover off, make sure you safe isolation, and you're going to be saying, let's change in this over here, or you're doing some fault finding. We got these cables. So what we have here, really basically, is we have, so just talking about from a switching point of view, the blue is the neutral and the yellow green is the earth. That's our protector. So that's going back to all this casing here and all these metallic parts. So if anything does go live, it should pop the fuse. It should take it out on the fuse box. So what we're going to be talking about really is the other three cables that are on here. So we're going to ignore those because they're not really part of the switching. So we don't want to overcomplicate things. So on this 3-port valve, we have the blue one down there, sorry, wrong way around. There we are. We have 3 wires. So we have grey, white and orange. So we're starting to break down from the 5 wires down to 3. And these 3 actually do the switching. Okay, they do need the other 2, but let's not complicate the system at the moment. So we have a white wire. Now the white wire goes to our heating on, and our grey wire is our hot water off. And then whatever the switching is, it comes out on the orange, and that's our then switch out wire. So the grey and the white are power that goes in to tell this to move, and then the orange is once it has moved, then that's almost like it's confirmation to turn on the boiler, to turn on the pump at that point. So the way I remember it is grey is for the water, like grey water, which is for the stuff that comes out of our showers, baths and sinks. So that links in. So that's our voltage in for hot water off, not hot water on. I'll go through that in a sec. And then our white is our heating wire. So when we have heating on, we have a voltage onto there. And once it then gets in position, we get a voltage come out of here, and that turns on the rest of the boiler and the pump if the pump's powered separately. So what do we have in here? So we have a servo motor, and that does the moving. I'm not quite sure if you can see it there. At the bottom, I've got a little screwdriver just to here. It's all back to front on the video. At the bottom there is 2 micro switches. Now these 2 micro switches are really important. So as it starts to move round, the motor starts to move round. If it's in one position, it will then do 1 click and stop. If it's in another position, it'll do 2 clicks and stops. And if it gets no voltage at all, or gets 1 voltage, then it won't move at all, and it allows the hot water to flow. So that is a 3-port valve. Okay, so don't get too worried about them. Don't get too sort of upset. And, some people go into a bit of a panic. I've had guys here, very experienced, more experienced than me, actually, within the plumbing and heating industry, turn up and then they get a bit of an electrical problem, and that is it. They go into full meltdown mode. I do quite a lot of the technical calls here at Gaslec to do with the electrical side. So I was digging through the bin, really. I was about to throw some bits away. So we have this old programmer. Now this programmer this one was made by Drayton, and the warranty expired in May 1996. So this is an old one. But do you know what? They still make them now, Drayton and Honeywell, and there's probably a few other manufacturers out there. A really basic programmer that is sort of stood the test of time. So on the back of here, this is the base plate, okay? Very common base plate. We've got neutral, live, 1, 2, 3 and 4 that are written onto here. So these are typically screwed to the wall. And I don't think I've ever come across one that we've swapped out that have actually been different within the lineup of the 1, 2, 3 and 4s. So then on the back here, it'll then say to you, if you can see that, it'll tell you on that sticker what cable goes to what. So we have live and neutral. They're the permanent live going in to power the whole thing up, make all the screen work. So that's standard stuff. We're not going to worry about ourselves with that. Then 1 and 2 are off programs, and 3 and 4 are on programs. So on here, hot water off is 1, central heating off is 2. We don't usually get involved with that one. And then 3 is hot water on, and 4 is central heating on. Okay. So what's really important is that on here it's got a hot water off. Okay. And what we need to make sure is that hot water's got two states really. So, well, actually, first of all, when we come out of the programmer, so I'm jumping ahead of myself a little bit here, guys. It comes out of the programmer and then goes into the thermostat, whether that's a hot water cylinder stat or whether that goes onto the wall thermostat, whichever you got, a digital one, wireless one, mechanical one, doesn't matter for this sake of this conversation. And it goes off to the stat, and is it what we call satisfied or calling for heat? So that does it want heat or does it not? Is it happy? Is it not happy? Either way, however you want to see it, it's just a switch. So this is a switch. So this is then on as a switch. It goes down to the thermostat. And is the thermostat calling for heat? Yes, it is. That's another switch. That will then click and then come back to the wiring center. And so what I'm going to try and get through to you guys is it's not that complicated. So when we've got hot water only on, it does not go through, or wrong one, it does not go through this 3-port at all. So hot water on means there's no power to the heating on or the hot water off, which means this is in a completely relaxed state and the water will pass up and come through the B, because that is the sort of the unsprung rest position of the valve. And then it'll run, and then the thermostat or the cylinder stat or the timer will click out, whichever comes first, and then it will turn the boiler off and the pump eventually. It might have a pump over on, but we won't worry about that for the sake of this conversation. So when the hot water is happy and it's turned off, we then get a power come out of our programmer, which will be on here, will be hot water off, which will be number 1. So number 1 on here will go live. From here, we don't have to link these out, by the way, and we'll then come down the grey cable because it's now hot water off. So what does that mean? It actually picked up the wrong valve again, guys, sorry. What they'll actually do is that'll move the valve, the ball, into the central position. Okay, remember we've got no demand at the moment for heating on or hot water on because it's just heating off, hot water off. So it will just move to its first micro switch position and it will sit in the middle. And so now, if we now go and demand heating on, it'll move with hot water off, it'll move all the way over, hit both micro switches, and it will now come up the AB and go off on the A, and it's moved over to that position. So now if we then get to that position and we're working away and it's all going lovely, we've got the heating on, and then the hot water demand comes on, then what will happen is the hot water off drops out and it moves back into the central position. So it's really important that the hot water off is an important wire, and I think a lot of people up and down the country get mixed up with this hot water off but wire. The hot water off, but it's a live wire. Why is it off when it's on? You know, all those sort of things. They're going down the sort of the wrong rabbit hole with them all. But you just need to know if it's off, then it combines off. And what we do a lot of the time is the cylinder stat, where it's got the common goes in, it's either like a light switch, you know, it's either on or off as it comes through, and in the off position we bring that wire back into the hot water off as well as of the program, and we combine them together and then bring that into the grey wire of the 3-port. So obviously when these things are a bit of a bird's nest, you just want to sit back I have a head torch on, sit back with a good bit of light and write down. And if you've got one of those chock block types that have got the many sort of rows of the screwdriver terminals, what you might want to do is just go through and start, when you identify it, left to right, 1 to 20, wherever it is, and start writing down what you believe they are on a piece of paper to start with until you sort of get your head around it all. So that's on the 3-port side, which is probably the most common that you're going to come across. And I'd say actually the 2 ports, and I keep picking this one up by mistake, it's just a switch. So once again, we've got a power cable and all it does is open and close. And when it's open, it sends the switch once again up the orange, and then it turns the pump and the boiler on. And when it drops out, it closes the waterway and turns it off. So these are normally called the S-plan, where you'll have one for heating, one for hot water, but ultimately these things could go anywhere. You can have multi-zone heating in your house, so you could have 1, 2, 3, 4, 5, 6 zones actually of heating, and all these are lined up next to each other, and then are just opening and closing as per. So the good thing about the reason why we use the orange switch is that if we start getting all the live wires that are coming in, so here on this 2-port, we have neutral and we have earth, which are standard. We're not going to confuse it. But on here, we have grey. Now, grey on a 2-port is permanent live. So that just livens the thing up so it stays there. So we'll get that one out of the way. So we've got live, neutral and earth. And I don't know why they have grey for live, not permanent live. I'm not so sure on that one. Don't make too much sense. And then we've got the brown, that's our switch live in, whether that's coming from the hot water side, whether that's coming from a heating side, or whether that's coming from wherever. It doesn't matter where it goes from this side. But as soon as you hit that switch, the motor will move around, hit the micro switch, and it will come out on this orange. Now every single 2-port, every single 3-port comes out, has a wiring diagram. And if you do Google it, there are some really basic wiring diagrams that sometimes I refer to if I'm getting a little bit flustered with the colours, and it'll run through what we do have. But just remember, whenever you see these orange wires together, okay, so if you've got a 3-port, you just have the one, that is the switch live out that will turn on the boiler and turn on the pump. So personally for me, first things first, if we're working on something that's live, be careful if you're fault finding, but what voltage is this wire sitting at? And if this wire is sitting at 0 and the pump's not on or the boiler's not on, well, there we are. Why is that not on? And then work backwards from there, okay? But once again, just be super careful with the electrical side. I mean, I have had where we've taken the cover off and then getting little sparks on terminals where they're too loose, and things are going a bit wrong inside. So if you're ever concerned, just turn it off and call up somebody that's a bit more confident in yourself or competent, whichever way you want to see it. So that there really is just a 2-port valve. Oh, another thing I just want to go through. So sometimes on these 2 ports, there's one I made earlier, these servo motors can fail. I think they're designed to run, this is a Honeywell one, I think they're designed to sit at about 55 degrees, so quite hot actually. But these motors here, if you take that little screw out, and it's got this little twist connectors, but just be mindful, untwist that and you'll get electric shocks. It is 230 volt. These motors can actually be replaced without actually changing the whole head over. So you might find that the synchro motor, getting that changed, may save the problem, or solve the problem, sorry, and be a lot cheaper as well. And you won't have to go into the wiring centre to unwire it. Just you need to make sure you isolate it safely, because you will get a electric shock. So, so the last thing to say on this, if you're dealing with, our little program here, the one that's going to go in the bin in the next couple of minutes, when you're dealing with smart thermostats, so you're dealing with your Tados, your Hive, your Honeywell T6R, wireless ones, Wi-Fi ones, whatever it will be, just think of that as the programmer and the room thermostat all built into one. So you don't have Some people get a bit mixed up. They go, right, okay, so I've got the Nest system. That's part of the programmer. Where's the thermostat? Well, the thermostat's part of it. So it just gives a switch live because it's dealing with the programming and the heating side all at the same time. The only thing it doesn't obviously have is the cylinder stat for the hot water. And so that's still whatever it is, but commonly it's just a wired stat that's on side of the cylinder taking the temperature. There are Wi-Fi versions, wireless versions out there. I think Honeywell do a kit where it's a Wi-Fi, a wireless cylinder stat and thermostat that comes in. I haven't seen one for a while, but yeah, I'm sure they do one. They do one, but I can't remember the last time I saw it. So that is the section there on the electrical. And I really do mean it, guys. If you're new into the industry, get your head around how that works. It isn't, once you get a bit of experience in it, it's not that complicated. And there are so many heating guys that just put their hands up in the air and take 2 steps backwards because it sort of dumbfounds them and they're not interested in learning it. But here at Gaslec, with the team here, we've got a guy doing a trial day coming up for this week. This is coming out on Tuesday. I'm recording this Monday evening, so we've got a trial day with him on Wednesday. And part of the conversation we're going to have with him is, what do you know about heating and electrical? Because it's something that comes past. Now, if he hasn't got a clue, and I'll teach him. I'll teach him all that he can take on board, not a problem at all. So, the history section. So this part of the podcast, a little bit of a history on our part of the plumbing industry that we use here. As I said before, I'm actually dyslexic, so I do struggle with some of the pronunciations on the words. So if I do get it wrong, email me in, call me an idiot, whatever you want to do, not a problem at all. But I'm going to do my best to say it because I've just sort of got some bits off the internet. So this week I'm going to do it on plastic water pipes. So we've had some people and they say to us, we're doing a job, do you use copper or plastic? And I say generally, if you can see it, if we're doing like a whole heating system, if you can see it, it's copper. If you can't see it and it's practical, we'll do it in plastic. The plastic material really has come on long leaps and bounds over the years, and we can work up to, you can have a coil 100 meters long, which means for 100 meters you don't have a single joint in it. Now in a standard house you ain't going to have a 100 meter pipe run, I know that for free, but it means that more than the 3 meter of the standard pipe size that it comes in, you can have it running through from the front to back of the house without any joints. And so without any joints, that's reducing the points of failure. So even if you're sweating it, if you're pinching it, or if you're going through loads of joists and you drill all the way through the centres of the joist, and in my personal opinion, a water pipe running through the middle of the joist is a lot safer from screws and nails and floorboards rubbing, that's a big thing on old copper pipe, than it is by notching out the top of the floor and then floor joists and then laying the boards just over the top of it. I think we get a lot less creaking and squeaking as well this way by going through the centre. And of course with that we can feed the pipe in and thread it through. We can't do that with copper pipe. You'll end up doing it with loads of stupid little sections and loads of joints all the way through. And of course the joints are a point of failure. So we use HEP 2O here, made by Waverin, I think the way you pronounce it is the manufacturer of it. So HEP 2O is the product that they make. I find that it's a bit more flexible than the John Geist for the Speed Fit product that they sell. The fittings have got better. They used to have this bit of a difficult key for them to sort of release. They've come out with a keyless release system. One of the things I didn't like about John Geist, they brought out a little clip to go over that little, that little release clip bit. And I did actually have one, and when it expanded, the release clip hit the piece of timber and it popped itself out, because that's the way you sort of release the pressure on the clamping system for the pipe. So we've gone over to HEP 2O, and predominantly that's what we use here at Gaslec. So it does have its places. You can't use it on gas 100%, but it does have its place within the plumbing industry, like anything, I think. Here we go. Polybutane, the product that it's all made out of is a synthetic plastic derived from the petrochemical byproducts, particularly isobutane from the crude oil or the natural gas. Now, this was a big thing that come in sort of into the plumbing industry sort of in the 70s. And it was all the big American companies getting through a lot of natural gas, getting through a lot of oil. And as we know, plastic is a byproduct of that as we then take it on board. That's why the plastic industry is so big. And when you heat it up, and burn plastic, it all goes black and smoky, just like burning oil as well. So it started becoming, in one form, sort of quite busy in the 70s in North America, Canada, and then in sort of around sort of the 95-ish era, we started seeing it being broken down and creating loads of leaks. So that was in its one form. So then over the years, it's got better and better. And it's not the pipe that it used to be, so just be sure of that. And back in the 70s, it was called the pipe of the future. I think that was around with the 70s big boom where we had all the copper shortage as well. So that's sort of, maybe it was the development wasn't as stringent as it should have been bringing it in. So Shell was one of the companies involved with the development, but also a company called DuPont. Which is a big American company. And they invented materials like nylon, Teflon, Kevlar, neoprene, just to name a few. So they take, neoprene, we use that in wetsuits, don't we? For those who do a little bit of diving and surfing. So, as I said on there, the early materials was actually not very good. The chlorine in the water ate it through. But Waverin and the Hep2O product, it now comes with a 50-year warranty. So that's how much the confidence they got in their system. But when I was reading that, when I was knocking this little bit up here for the podcast, I thought, when does the warranty period get ridiculous? So I thought 50 years, they used to do 20, they did 10, 25, now they're up to 50. Well, I won't tell my true age, 49, but, that puts me at 99 years old. Really, are they going to go back in 50 years' time with a till receipt saying, I bought this plastic fitting from you sort of 49 years ago, can I have another one, please? Is that practical? What's the next step they're going to do? 100-year warranty? Then what's someone going to come out with a 200-year warranty? At what point do we say this is absolutely ridiculous on a warranty of a piece of plastic? But that's the confidence they got in there. That's not my place to come out with it. So what else have we got coming up? So this week, I've sort of hit the ground running on the Monday. We've got quite a few quotes out. I've got 5 quotes for boilers. I've got to do another one this evening, get that typed up. I did one earlier on today. So that's 2 today. I think I'll have another 2 tomorrow. So it's starting to pick up that time of year. People are thinking, kids are going back to school. You're looking out the window at 5 a.m, it's dark. You're getting home at times now 9 o'clock, and it's definitely dark outside here over in Gaslec Towers in the historic city of Rochester. People are getting a bit more proactive on that. Let's get that done. We're over that. We're going to be turning the heating system on. I think we've got another week of warm weather still in the planning of the forecasting, but it is getting a bit chilly at night time at the moment. So we've got some proactive people there looking to upgrade their system before they turn it on properly. But one of the things we've got a big commercial sort of space that's the job's starting on Wednesday. And it's going to be like an event space in Chatham. I won't go too much into it and who's going to be running it, but it's going to be like book it yourself, supply a bar, the resident DJ or your own or a band or whatever it'll be. So quite a flexible space, and you don't really see that around. You got like hotel spaces, and they want more control over it all, but this is going to be quite a flexible space. So super looking forward to how the business goes with this, with the guy. But one of the things we've got to do, and I'll do a video on it, we've got to tap into the waste system to bring some wastewater in. And they use Infusion World. So I'll do some videos and bits and pieces up and put it up onto the social channels. But one thing I need to do is when we do the Fusion World, I've got to cut a hole to put a strap onto the side of the waste. And then as I put that in, then what I've got to do is glue it on. And then there's like a heating coil, so I've got to get it clamped on. Then there'll be a heating coil, and that'll heat up, melt the surfaces, and then that'll go cold. So what basically at that point, I've got to make sure that no water is coming down through the pipework. So I've gone and bought, which I'm going to show you guys, an inflatable bag. And so this is to stop, so this is actually to do pressure testing, but the size of the pipework, I needed to get a sort of a bigger size. So on the pressure testing side, what we have here, and sometimes they'll have a bung, like a bung, and you wind them up and they go in because they've got an access point. But the access point is actually quite small on this big pipe system. So I couldn't actually get a whole size bung into the waste pipe to screw it by hand to isolate for the water. So what I've had to opt for is a bag. So basically, it's got a maximum PSI of 6 onto the bag. Didn't work that one out, did I? And then basically just blows the bag up, and it's got pressure tested maximum 6 psi actually written on it. It's upside down there, guys. And then we just lock that off. So I can blow that up with a gentle pump to 6 psi. I wouldn't put it obviously on the compressor. And then we put that inside the soil pipe, blow it up, and then that will stop any of the little bits of moisture coming down. And we just open the valve up and it goes down. So I've got a little soil elbow here, so we just pop it into there, and then just for the sake of the demonstration, and there's the bag inside, and it's nice and tight inside there, and that's just me blowing probably what 2-3 psi, so not a lot at all. So we get a tiny little pump on that. That'll make quite a nice little seal, and then just release that, and it'll drop itself out. So we've got that going on, which is pretty cool. So yeah, there we have it, guys. So I hope you've enjoyed this week's podcast, and I hope I've helped you understand on the electrical side, on the trying to get your head around it. And once that penny starts dropping, and once all those things start clicking into place, actually it's not scary at all. It's just switches. If you just think about it that way, it's the programmer switches, the thermostat switches, it sends a cable down, voltage down to the wiring center that goes off to the 3-port or the 2-port. That moves over, that switches, the wire comes back and then turns it back on. And that it really is it. When you're fault finding, at what point is the switching not happening? So you can either go to the end, which is the boiler pump, boiler live and pump, which is the orange, and work yourself back, or you go all the way to the front from the programmer to the thermostat to the 3-port, 2-port, and then through the wiring center to that. So you can do it either way, but very much you typically, one of the little tips, and I'll give you this for free, guys, you've listened to this all the way to the end. One of the little tips here is these micro switches. So this one's here just on the back. I don't know if you can see that there. That's all back to front for me. Just inside, there's a micro switch at the bottom. If you get your screwdriver on that and you click it down with your screwdriver, and you click the switch down, the little micro switch, and it all fires up, you know that motor's not bringing that armature all the way across. And so from then onwards, it's all working. Boilers on, pumps on, it's all making a racket. Perfect, that's what you want. So then you know why ain't that micro switch being switched. And typically that will then be the motor's not moving. Why is the motor not moving? Is the motor faulty, or is the spindle, the shaft that it goes onto, is that too tight? Is that seized up? Doesn't that need freeing up? Would a bit of take the head off and give it a bit of a wiggle with a set of pliers. But that's when you can start honing down and narrowing down your search for the issues there. So, guys, that's the end of the podcast. Thank you very much indeed. I've rattled on for ages. Hopefully, this has been of a help. If you've got any questions, it's podcast@gaslec.net. If we could help with anything here down in the southeast, send us an email or office@gaslec.net. I rattled on now for 40 minutes. It's the longest podcast I've ever done. So thank you very much for bearing with us, and thank you very much indeed, guys. All your help and support. Please like and subscribe. Cheers for your ears and all of that. Good night.